I'm going to be talking about properties of special parallelograms, and this is day 1. So let's remember from yesterday the properties of regular parallelograms that we learned. So first off, we know that the opposite sides are parallel. The opposite sides are congruent. We also know that opposite sides or opposite angles are congruent. We also learned that consecutive angles are supplementary or add up to be 180 degrees. And our last one is we learned that diagonals bisect each other. Now we're going to be talking about a rhombus. A rhombus is a type of special parallelogram. So it obtains all of the properties of parallelograms. So the properties of rhombuses are the properties of parallelograms. So all of the 5 properties of parallelograms are going to apply to rhombuses. But there's a few special ones that are going to apply as well. A rhombus, all sides are congruent. So each side is congruent to each other. All of them are equal. They're congruent. The next one is diagonals are perpendicular. And if diagonals are perpendicular, that means that they make a right angle, because perpendicular lines give us right angles. So all of the angles in the middle where the diagonals meet are right angles. And the last special property of rhombuses is that diagonals bisect opposite angles. That means that this angle right here is split into 2 equal parts. Same as over here. So those are all going to be equal to each other. Same as down here, these angles are going to be split into 2 equal parts. Those are going to be split into 2 equal parts. So all of those pieces are equal to each other. So these are our properties of rhombuses. It obtains the properties of parallelograms. All the sides are congruent. The diagonals are perpendicular, and the diagonals bisect opposite angles. So we're going to be using these properties to solve some problems with rhombuses. So the first one, it says find the measures of the numbered angles in rhombus ABCD. So I have the 61 degrees down here, and I'm looking for angles 1, 2, 3, and 4. Well, the measure of angle 1 is very easy. Since those blue lines are diagonals, I know that they are perpendicular and they make a right angle. So measure of angle 1, easy, 90 degrees. Okay? We also know that opposite angles are equal. So I can say that measure of angle 3 is 61 degrees and measure of angle 2 is 61 degrees because opposite angles are equal and those diagonals bisect that angle into 2 equal parts. So measure of angle 2 and measure of angle 3 are equal to 61 degrees. And our very last one, we can use the triangle sum theorem. We can say 61 plus 90, which is 151, and we can subtract that from 180, and we get 29. So the measure of angle 4 is 29 degrees. So that triangle sum theorem is popping back up, and we can use that to find the measure of angle 4. Let's look at another one, okay? This one, we have G, the measure of angle G, which is down here, which is 118 degrees. And we're looking for angle 1, 2, 3, and 4. Well, that means we have to find one of the angles D or F. So I'm going to look for the angle F. And I know that angles that are side by side or consecutive are 180 degrees. They're supplementary. So to find F, I can say 180 minus 118, and that gives me 62 degrees. So angle F is 62 degrees, but I'm looking for 3 and 4. Well, I know that that diagonal bisects it into 2 equal parts, so I can divide that in 2. So angle 3 and angle 4 are both 31 degrees each. And we know that opposite angles are equal, so 1 and 2 are also 31 degrees. So the measure of angle 1, 2, 3, and 4 are all going to equal 31 degrees. So we're using our properties of rhombuses to solve. All right, let's look at another problem. This one is just general rhombus questions. The first one says, find the measure of angle DAC. Find the measure of angle DAC. Well, DAC is right here. And if we look, we have the measure of the angle right next to it. And we know that those diagonals bisect those angles into 2 equal parts, so we know that this is also 32 degrees. So that one's really easy. Okay, next one, find x. So we're going to see where x is at. X is pointing to this angle right here and this angle right here. Well, a rhombus has the same properties of a parallelogram, and a parallelogram has parallel lines. And when we have parallel lines, we have alternate interior angles that are equal or congruent. So we can say 5x minus 8 is equal to 3x plus 24, and we can solve. We're going to subtract our 3x. 2x minus 8 equals 24. Add the 8. 2x equals 32. So x will equal 16. All right, let's find y. Where is y? Well, y is at this angle right in the middle where the diagonals meet. It's right here and right there. And we know that diagonals are perpendicular, so they make 90-degree angles. So 3y is going to equal 90. Divide by 3, y will equal 30. So we have to know our properties, and we have to know how to use them. All right, got one more left. The following parallelogram is a rhombus. Solve for x and y. So we have a rhombus, all the sides are equal, and so let's solve for x and y. Well, x is right here, this angle, and then we have 85 degrees. Well, we know that angles that are side by side or consecutive are 180 degrees, or supplementary. So we can say 180 minus 85, and that will give us 95. So x will equal 95. And the y values are on the sides, and we know that all sides of the rhombus are equal. So we can say 2y plus 3 is equal to 5y minus 6. And then we can solve the equation. So y will equal 3.